Hey guys, welcome to KnowledgeHunt. I hope all you doing well.
So today we will be covering some tricky collection framework interview questions here in the descending order. So please stick with me till the end, and now let's get started without any delay. So the very first question when any interview can ask is to explain the collection hierarchy. So with this question, if answered properly, you have the chance to let interviewer know that you know the whole collection framework hierarchy, whole and soul. So it's like whenever you try to explain any of the or every of the element of this hierarchy, just add 2 or 3 important feature of that particular collection which makes it unique from the others. So let's see how we can do that. So whenever anybody asks you how to explain collection hierarchy, say that it starts with the collection interface. So what is the collection interface? Collection interface is a root of the collection framework in Java, and most of the collections in Java are inherited from this interface only. But the only interface which does not implement or extend this particular collection interface is the map interface. So now let's see the hierarchy ahead of it. So the 3 basic interfaces which implements this collection or extend this collection interface is list, queue, and set. And the map interface does not extend the collection interface because of the few reasons which I will cover next in the video. But first understand what is list. So list contains the ordered elements, it can include the duplicates, and it supports the indexed based searches, random accesses, but elements can easily be inserted irrespective of the position. So what does that, this is how you explain each and every of those hierarchy elements, that they contains ordered elements and may include duplicates and allow you to have index based searches. So these 3 things make it a unique collection as a list because the other 2 and another 3 does not have these unique features. So let's consider the second one, the set. Set does not define any order for the element, hence index-based searches are not supported, and it does not contain the duplicate. So this is how the list and set are different from each other. That is, it was allowed to have an ordered insertions, and it is allowed to have the index-based searches. It is not allowed in set. It can basically contains the duplicate elements, but set cannot contain the duplicate elements. So can you see how we can differentiate them? So now let's cover the another ones. So java.util.queue, it follows the FIFO approach. So you know that the queues are first in, first out. That is, the elements are added at the rear end and removed from the front end. So this is the unique property of the queue. And the last one, which does not actually extends the collection interface, is Java util map. It represents a key value pair. So it's always in the form of map bracket k comma v. So k defines your key and v defines your value. Now map interface does not implement the collection interface, and it contains only unique keys but can have duplicate values. Now let's cover the hierarchy of each of these interfaces ahead so that we can have some classes which implements these interfaces, because you cannot code with just interfaces. So the first one we are going to cover is list interface. So this particular list interface is being extended by the few classes. The first is array list, then the linked list, then the vector, and basically the stack is the one which the class which extends the vector class. So the very first we are going to cover the unique elements is that array list. Array list is dynamic resizing, and whenever the particular list is full and you want more elements to be added, then it automatically resizes to its 50% of the original size. And basically the very important unique about this particular array list is it is non-synchronous. Then linked list, basically this particular class implements not just list interface but also DQ interface, and I'm going to cover this DQ interface in a few minutes in the next slides. But understand first that linked list actually maintains the insertion order, and it is non-synchronized as the array list, but it does not support accessing elements randomly. You can only iterate through linked list through list iterator. That is the only way you can iterate one by one, and you cannot just go on and do the index based searches as you were able to do in the array list. So this was a difference between array list and linked list. Now the vector is a synchronized one. So this is the difference between array list and vector. So this is how you're going to explain it to the interviewer, so that he will just by one question he will be know that you know everything about each of these collection interfaces of classes. So vector is synchronized. It maintains the insertion order, and it is thread safe. So this is a very important point of vector. This is basically a legacy class, but it is very important because it is a thread safe collection. Basically, multiple threads when working together, it is a complete safe thing to do. Now, the vector increases its size by doubling its array size. So this was a difference between array list and vector. Array list increases its size by 50%, but it just doubles its sizes whenever the capacity of this vector is completed, and you want more elements to be added to vector, then it will exactly double its size. And basically, it's a legacy class, but it's an important one. Now the last one, stack. Like the queue we have seen previously, queue was first in first out, but the stack is last in first out. That is, elements are always added and removed from the one end only, that is the rear end. So that was all about the list interface. Now let's cover the set interface quickly. So the set interface is actually being implemented by two classes, which is the hash set and linked hash set, and one interface which is sorted set. And that particular class which implements this particular interface. So this is an interface, and these are all the classes. So these are the three classes, because interface is of no use if there is no implementation of that particular rules which are defined in interfaces. So basically, set is extended by a sorted set, which is an interface, which have the implementing class, which is the tree set. So let's see about each of them. First, about the hash set. So basically, hash set actually implicitly implements a hash table, and it contains only unique elements. So this is unique about the hash set, because set contains only the unique elements. Hence, the hash set also contains the unique elements, but it implicitly implements the hash table. So there can only one null element that can be added, but not more than one null element can be added to this hash set. And it is it is unordered. Basically, there is no order while you put elements in the set. It can be randomly organized. It does not maintain the order of insertion of any of the order. It just put it in an unordered fashion. Now, next important thing for linked hash set is that it is the ordered version of hash set, which maintains the doubly linked list across all its elements, and hence, since it's a doubly linked list, you can always go in one direction. It preserves the insertion order for you. So that was important difference between hash set and linked hash set. Now let's go to the another interface which implements the set, which is sorted set. So all the elements of the sorted set must be implementing the comparable interface. Because why do every element need to implement the comparable interface? Because this particular set has a particular unique feature that it always stores the elements in the ascending order. That means it actually sorts the element you store into this particular collection. So to make sure that all the custom objects are also stored in ascending order, all those custom objects or the elements of the set must implement the comparable interface, and hence tell them like how to compare if 2 or 3 elements are added into this particular sorted set. So this is all about the interface, that it always stores in the ascending order. But what about the class which implements it? So the tree set is a class which implements this particular thing, and basically the tree is used as a storage thing. The one of the most famous balancing binary search tree we have is red black tree. So in the behind in the curtains, red black tree is used to store the elements for the sorting purposes, and objects are stored in a sorted and ascending order always. That is why a tree set is used, because a tree is much more faster in red black tree, and even insertion is easier. So that was all about the set thing. Now let's move towards the queue interface. Now quickly, the queue interface hierarchy says that there is only one implementing class for the queue directly, that is the priority queue. The another interface which extends the queue interface is DQ, and the class implementing this extended interface is ArrayDQ. Now let's see the unique thing about the priority queue, queue and DQ and array queue. So queue, I have already told you, it is first in, first out. That means everything is entered or exits from the rear end only. So whatever element gets into the collection first is the one which is removed first. Now, what is the unique thing about priority queue? So priority queue is nothing but a queue with the priority which is associated with each element. So suppose I have added 5 elements, all these 5 elements will have some 1, 2, 3, 4, 5 priority added, and always the highest priority element is served before the low priority elements irrespective of their insertion order. So it does not maintain the insertion orders the queue had, but it actually maintains those particular things with a priority number. So if the number of the particular element is higher, it will be served first than the lower priority elements. Now, that was the unique feature of priority queue. The another interface which extends this queue interface is DQ. So it's nothing but a doubly ended queue. That means elements can be added and removed from the either end, either from the rear or from the front. Now this was about the interface, but what about the class which is implementing this interface? Is array DQ. So this is nothing but a way to apply resizable array in addition to the implementation of DQ interfaces. So not only it is a doubly ended queue, but is a resizable array implementation, and hence it has no capacity restriction. Like you can add as many number of elements you want to add in this particular array DQ. So that was all about the queue interface. Now the last one, the map interface. Remember, this map interface is the unique interface in the collection hierarchy. Why? Because it does not extend the collection interface. Now let's see the hierarchy first, and then I will tell you why. So the two classes which, this was an interface. So two classes which implements this map interface is hashmap and hashtable. Now we have another interface which is sorted map. And that particular sorted map has an implementing classes, which is a tree map, something similar to set, if you can recall or remember. So let's see the unique feature of the hash map. So hash map is nothing but a non-synchronized natured collection, and it contains only one null key but can contain multiple null values. So why? Because keys are always unique and values may or may not be unique. It's not a necessary condition. But keys for the map should always be a unique element. Hence, only one null key, which is a unique element, is allowed, not more than that. But multiple null values can be allowed in the hash map. Now, what about hash table? Hash map was not synchronized, but hash table is a synchronized collection in nature, and it does not allow any null key or null value. So this is a very important difference between hash map and hash table. It will for sure be asked in an interview, like what is the difference? Then you have to tell that. The two main differences that this is not synchronized, this is synchronized, and it does allow one null key, multiple null values, but it does not allow neither the null keys nor the null values. Now, moving ahead to sorted map, all the entries are maintained in the ascending order here. So this is how the sorted are always, right? It is always sorted. So it's the ascending order in which the objects are maintained. So the best way to do that is to implicitly implement it red-black tree implementation for the sorting purpose, and it cannot store any null keys just as the hash table. So that was all about the map interfaces and the collection complete hierarchy. You should remember each and every unique thing I've told you in this particular question. Now let's move ahead to the another question. The very important question they ask you just after the collection thing is, most probably, is that why map does not extend the collection interface. So this is a very important question. You need to understand that map interface is actually having a key value pair structure, whereas all the collection interfaces is actually collection of just objects which are stored in a structured manner with a specific access mechanism. And the main reason as to why map does not extend this is that there are basically how do you add elements in a collection? So if you add an element in a collection, you always use add method, where you pass an object and that particular object will be added to the collection interface. But the collection interface, which is map, does not support just one array, one element, but also supports a key value pair. So it's like put k comma v, which is key and v both, key and value both. Hence, it cannot extend the collection interface. So it's basic, but still it is an integral part of Java collection framework because it's the only collection which can have a key value pair in it. So it's a very unique but a very important integral part of Java collection framework. Now I'll give you an example. This is something which is documentation of these two classes. So suppose I have one list for you. So this is the implementation of list interface. It actually extends the collection interface, but this map does not extend any of the collection interface, but still it's a very integral part of collection interface, collection framework. Now, the third question which lies here is what is the difference between fail fast and fail safe iterators? So, I've already told you that, like when I was telling you about the linked list, right? So, I told you that to iterate or to access the elements, you always need an iterator. So, there was a linked list iterator there. So, what's the actual difference between the two types of iterators we have, the fail fast and fail safe iterators? So, this is a very favorite question of an interviewer. It says that fail fast it throws concurrent modification exception. So, this is the very important thing which actually differentiates the fail fast and fail safe iterators. So, when one thread is iterating over a collection object and other thread is structurally modifying, or like it's a read and write operation, by modifying the underlying objects of the collection, then they are called fail fast. Why? Because they try to immediately throw this concurrent modification exception whenever they encounter such situation. So when two threads are simultaneously working on a particular iterator is working on a particular underlying collection, then concurrent modification exception is as soon as they found a situation, they throw it. But failsafe iterator does not throw any exception even if the collection is modified structurally by one thread over, because they work on the clone of the collection. So this is a very important feature. Whenever you say that the fail fast iterators always throw a concurrent modification exception, but the failsafe does not throw that particular exception, then the interviewer, the next question will be, why is it that failsafe does not throw an exception? So the reason why it does not throw the exception is that because it works on the clone of the collection instead of the original collection, and hence it allows you to do it simultaneously and later on they merge it all. So that's the very main difference between fail fast and fail safe iterators. Now the fourth question, which is very important question from the collection interview perspective, is that what do you understand by blocking queue? So you know about queue, it's the first out thing, right? So Java blocking queue interface, which is java.util.concurrent blocking queue. So I have told you the queue is of Java util class, but this blocking queue is of a concurrent package. It basically represents a queue which is thread safe to put elements into or take elements out of it. In other words, multiple threads can be inserting and taking the data concurrently from the blocking queue without any concurrency issue arising. So can you see why blocking queue is of concurrent package? Because there is no concurrency issue. Multiple threads can work without any issue on a particular collection which is queue. And how is it capable to do that? It's capable of blocking the thread that try to take the element from a queue which is empty, or it actually blocks the queue until there are elements into it, or when the particular queue is full, it prevents the particular thread or blocks the particular thread to put any more item into that particular queue collection. So that is why we have this blocking queue, and blocking queue is very important because it is concurrent or thread safe in nature. So that was all about the blocking queue. Now, what is the difference between synchronous collection and concurrent collection? So this is very important and very favorite question of interviewers. And you will for sure be both are thread safe. Then what is the real difference in it? So yes, the synchronous and concurrent collection are both thread safe and they both provide the thread safety. But the real differences lies in the performance, scalability, and how actually they achieve this thread safety. Fine, I understand that they are thread safe, but how do they achieve it is the real difference in it. So synchronized collections, for example, Hashmap, are much more slower as compared to their counterparts, that is concurrent Hashmap. And why is that? So I'll show you. So what will happen in the basic synchronized collection, whenever you when one T1 thread, okay, is writing something on the particular segment of the complete collection, this is a complete collection. So what will happen? The whole segment, this whole particular collection is actually logged, and no other thread can actually read from any of these remaining segments. They all have to wait until this particular operation is completed. So this was about the synchronized collection. Now what about concurrent collection? So in the concurrent collection, if one particular segment is blocked by T1 thread, then T2, T3, T4, they all can operate on the remaining particular 2, 3 or 4 segments without having any issues. And this particular operation is called as lock stripping. It basically, what the concurrent collection do is, it actually divides a whole collection into multiple parts. And if one particular segment is having the right operation, then all the other threads need not wait, but they can concurrently work on the other segments of the part and they are open to them. That is why it is much more faster and efficient. Now, the next important question about the hash map and the internal working of hash map. So they will always expect you to have the complete understanding of how it actually works. So let's see how it works. So how does hash map work? So hash map in Java works on a hashing principle, where a hash function is the one which is used to link the key value pair. So whenever you provide a key to the hash function, it provides you some value, and that value is nothing but an index, where your hashing will make your value stick into the particular hash table. So the next important point here is, it's the object which is map.entry, which is nothing but a Java object which contains both key and value objects are stored in the hash table, where you can use two particular operations, that is put operation to put the object or the map.entry object of the hash map, and retrieve the object using the get, and you pass the key and you will get the value out of it. So this was the basic, very abstract way of understanding how a hash map works. It basically works on hashing principle using the hash function. So hash function will do nothing. It will take your key, it will generate a particular index, and that index will be the index number of your table where you can find your key or you can put your key. So that was the abstract one. Now, when you call a put method, that is when you want to put something into the table, the hash code method of it will actually take your key, it will calculate the index as I have told you, and that will be your bucket location where you can store the value object. I will show you diagrammatically in a few seconds. Understand this and I'll repeat it for you also. The next important thing is when you try to retrieve it. So you will call a get method. You will pass your key object. So this is the way you can pass the key object to the get method, and it will lend you up at the same bucket and you can retrieve the value of that object. So did you get an overview of it? Now let's see that programmatically. So this is my hash table where this is my entry object. So entry object, remember this very importantly, that the key value pair is always stored in the table. It is not only just the value which is stored, okay? It's always the key value pair which is stored in the hash table. Now I'll tell you how put and get works here diagrammatically. So if particular object comes, like I want to store a particular key and I have given it to the hash code function and it generates me an index. So suppose the index comes as 0. So what it will do, it will create an entry object with the key and value both, and it will add into this particular location. So this is my location, it will add here. Now, if I want to get it, what it will do, it will again pass the particular thing to the hash code, and the key, I will pass the key to the hash code function. It will give me the bucket number. I will lend that at this particular location. I will fetch the value from here. Now, this was as simple as that, but did you ever consider a situation that there can be a chances of collision? So what will happen during that particular time when your particular two different keys will generate the same index? Because indexes are finite numbers 0 to 5. It might be possible that multiple keys may generate the same number of indexes. Then how will we handle that? So whenever you try to put something into that, where you have already a particular key value pair there, then a linked list is created here. Can you see this linked list? This is nothing but a linked list created. So again also, if another key has the same index 0, then it will see that this particular thing is there. It will again create a node with a key and a value, and it will append it at the end of this particular linked list. This is how collision is maintained when you try to put a new value which have the same hash code function generated from the key. But now what will happen for the get function? So this was easy, right? A linked list is created and so on. A long linked list can be created at the same index. But then when it comes to get operation, how it will handle? So when you try to get a particular value, so you will pass again a key and you will get the index, you will see this particular thing. So what it will do, it will go on from the first node. It will check and use the equals method. So if equals method passing the key says yes, the key is the same as the one you are searching for, it will return you to the value. But if it says the key is different and you have a different key that you are searching for, that will go to the next node, and so on. It will go on going to the next node in the singly linked list until you find the perfect equals returning true when the key matches and the value is returned by the map. So this is how key value pair gets into the hash table and gets retrieved from the table. So again, the same thing. If two keys return the same indexes, collision occurs, and if collision occurs, then what will happen? A new entry is stored as a next node of the linked list. A linked list is formed. Now the put method just appends the object nodes in the linked list, but in the case of get method, we need an extra check of equals method so that you can search the correct value. So it checks every key of every node, and if the equals return true, that means your both keys which you are searching and which is being stored in the table is the same one, or then only the equals will return true, then the map will return the corresponding value from the linked list. So importantly, remember both the key and values, hence both the key and values are stored in the table, because it is the key. When multiple collisions occurs, it is the key only which will tell you, yes, this is the value corresponding to this particular key. So that was all about the collection framework tricky questions. We have more tricky questions. If you seriously like this video and you want more such tricky questions, which I should cover, like the hash set and all, internal working of hash set also, just let me know in the comment section. I will create one more video for you. Thank you.